back to stuff that we've been talking about before. But the issue is now we have a little bit of context. Well, it's not really an issue. It's understanding. It's the relationship. We have context now to allow us to hopefully understand why we were doing some of the things that we were doing. Because we were actually finding, when we were getting homogeneous solutions and particular solutions and things like that, we were finding the solutions of three-dimensional systems, the intersections of planes and things like that. You would have answers in parametric form. We were actually doing it with higher dimensions too. That's why we would have some equations that were in terms of two variables rather than just being in terms of one variable. Right? So here we have two planes that are going to be intersecting one another. Right? So, but we only have two equations. So we're going to get the equation of a line. That line will be expressed in parametric form. So let's investigate. So we have 2, 1, 1, 1, 3, -5, 1, 4. I mean, if you want, and just to kind of even it all out a little bit, you could do something like this just to give you a sense of where the variables belong. We have 2, 1, 1, 3, -5, 1. We have the variables x, y, z. Or x1, x2, x3 if you want to have it in ax equals b form. All right. The issue here is we have a 2 by 3 matrix being multiplied by a 3 by 1 matrix. It doesn't quite feel right. Somehow giving us 1, 4. The reality is we have to assume a row of zeros. All right, so what we're doing is we're basically assuming that there is a third equation of 3 variables whose coefficients are all equal to 0. Right? So you're saying 0x plus 0y plus 0z equals 0. You're essentially talking about the origin, 0 vector. Right? So that's one thing that we can assume. But you could also just say, okay, forget about that and just jump right to this. So row reduce. Choose 1, 1, 1. Not 21. Reduce row echelon. We get this. Math bracket, clean it up if possible. Seems to be more than possible. All right, so we have x plus 6 over 13 z equals 9/13. Y plus 1 over 13 z equals -5/13. Which would be the same thinking as x equals 9/13 minus 6 over 13z. Y equals -5/13 minus 1/13 z, where z is equal to itself, some unknown free variable. All right, so we have we have 9/13, negative 5/13, and 0 for the particular component, plus some parameter t, negative 6/13, negative 1/13, 1. It should look and feel like the equation of the line. A parametrically defined equation of the line. Now in the previous unit, what we would do is we would call this x of 1, x of 2, x of 3. X of 1 equals this times x of 3, y equals this times x of 3, x of 3 equals x of 3. And then we would just leave this as an x of 3 multiplier. But because we know it's the equation of a line, we can define it parametrically as some independent variable that we call t. Right? But it's essentially the same idea. Right? But it adds a little subtext to it, which is a good thing, I think.